today we're going to take a little bit of time and summarize the last of our 4 different transformations that we've been working with, and that is dilation. So if you're watching this, that means you have already completed your dilations introduction and you have some ideas about how dilations work. What we're going to do is we're going to take those ideas and summarize them and add a little bit of information in with what you were looking at in your dilations introduction. So from your dilations introduction, you hopefully noticed a couple of things. First of all, a dilation changes the size of a shape. So we already talked about that when we introduced the 4 different transformations: translation, reflection, rotation, dilation. We said that dilation is one that changes the size of a shape. So that also makes the dilation a little bit different than the other 3 transformations. So it makes dilation a little bit different than translation, rotation, reflection, because translation, rotation, reflection all keep the shape the same size, which means all 3 of those make congruent shapes. They just move the shape somewhere else on a graph. Because the dilation actually changes the size of a shape, it doesn't create a congruent shape. What it creates is a similar figure. So that's where we get some connections to some things that we were working with a little earlier in the unit. We did a little bit of work with similar triangles, and we talked about what it means for shapes to be similar. So dilations create mathematically similar shapes. So it should still be the same shape. All the angles in the shape should still be the same. It just has sides that are proportionately bigger or smaller than the original shape. So a little bit of vocabulary to go with what you're working with. So all of the rules that you were working with in your dilations intro were all multiplying rules. So that should have given you a pretty big hint that multiplying causes dilations. So that amount that we're multiplying by, it has a name. It's called the scale factor. So you'll hear some talk about scale factors when you're dilating. Scale factor is just what number are you multiplying by. You were also asked a couple of questions in your dilations intro that most of you picked up on by observing your shapes. So most of you noticed that that number you're multiplying by, if it's less than 1, or actually between 0 and 1, because we don't want it to go negative. If it goes negative, then it's going to also reflect the shape, because remember, making things negative is part of our reflection rule. So if we have a scale factor between 0, positive, but less than 1, most of you figured out by observation that that's going to take your shape and make it smaller. So that's how you make a smaller shape. And if you multiply by something bigger than 1, that's how you're going to get a bigger shape. So that will make the shape bigger. So you can control whether the shape gets bigger or smaller based off of the scale factor, or the number that you multiply by. So the rule for a dilation, and that's going to lead kind of right into some notes about dilations, things you need to be aware of. So to get a dilation, we are going to take whatever our scale factor is, so whatever we want to multiply, and we're going to just multiply that scale factor by both coordinates. So we would do the scale factor times x, and then that same scale factor times y. And that leads us right into some notes about dilations. So another thing that a lot of you guys realized from your dilations intro, you started with a square. And one of the questions that you got asked when you were done was which shapes made squares and which shapes didn't. So 2 of them made squares, and 2 of them distorted the square and turned the square into a rectangle. And most of you guys in your questions that you're answering, you figured out the connection that the ones that distorted the square were the ones that weren't multiplying x and y by the same number. So that raises a really important point about dilations. X and y have to be multiplied by the same number in order to make a correct dilation or make a similar shape. If you're not multiplying by the same number, you're going to distort your shape. So it would be like the ones on the activity that the square turned into a rectangle. Well, those aren't correct dilations because they're not actually making a similar shape. They're changing the shape, and we don't want that. So that is a rule for dilations. Whatever scale factor you're multiplying by, x and y have to be multiplied by that same number for it to be a correct dilation. Now, there's also something else interesting that a dilation does, and I'm pointing this out because this is a common mistake that people make when they're trying to dilate shapes on a graph. And by pointing it out to you, hopefully you can avoid making that mistake. So, dilating shapes on a graph has an interesting side effect for the shape. So, dilating a shape also changes how far the shape is away from the origin, or 0, 0 on the graph. So, if you make a shape larger, that's going to actually push the shape farther from the origin. And the opposite happens if you make a smaller shape. So if you shrink your shape, it's actually going to pull your shape in and bring it closer to the origin. So that's something important to remember. When you're working with dilations on a graph, very rarely will you have vertices or corners of your shape that start and end in the same place, because the shape is either going to get pushed away from the origin or pulled in towards the origin naturally in that process of multiplying, which makes sense because we measure coordinates from the origin. So if we have a coordinate that's 2, 2, we're saying right 2 from the origin and up 2 from the origin. Well, if we multiply that, let's say we triple it and make it 6, 6. Well, now we're 6 away from the origin both directions. So it makes sense that multiplying the coordinates of a shape is going to push it away from the origin or pull it in closer to the origin, because that's how we measure coordinates. We measure coordinates from the origin. So a dilated shape, generally speaking, should not be sitting directly on top of itself. It's going to move farther from the origin or closer to the origin. The one exception would be if you intentionally translated your shape. So maybe you made it bigger and it pushed it away from the origin, but then you used the translation to move it back. So that would be using more than one transformation, though. A dilation by itself will change how far the shape is from the origin. So just to kind of summarize some ideas, we're going to look at an example problem. So we have a triangle, ABC, and it's dilated by a scale factor of 2. So the very first thing we're being asked to do is write a rule for the dilation. So we're going to use our notation for that. So our notation always starts with that X and Y that represent the original coordinate, and then the arrow that basically says do this. And we said our outline for the notation is to multiply X and Y by whatever our scale factor is. So since our scale factor is 2, the rule for this would be 2x multiply x by 2, 2y multiply y by 2. So you can take the scale factor and you can turn it into a dilation rule or a transformation rule. Second thing we're being asked to do is to graph both of these on the graph. So we're going to start by just putting the original triangle, so ABC. So A, I'm going to zoom this in a little bit, give us more room to work. So A is at 1, 1, so that's right there. B is at 3, 1, so that's right there. So there's one side of our triangle. And C is at 1, 4, so there's C. So that is our original triangle. Now, it says graph the image. Well, we have the rule that tells us to multiply everything, so that means we need to use the rule to figure out what our new coordinates are. So A prime, remember that's the notation we use for the image, A prime, B prime, and C prime. We're going to have to multiply all of our coordinates by 2, because that's the scale factor, in order to get the new coordinates. So if A is 1, 1, A prime is going to be 2, 2. B was 3, 1. B prime is going to be 6, oops, sorry, I got ahead of myself, 6, 2. And C was originally 1, 4. If we double that, now it is 2, 8. So in order to graph a dilation, you have to use your rule to figure out what your new coordinates are and then graph those new coordinates. So that means A is A prime. I'm going to switch colors just to make this a little easier to see. So A prime is at 2, 2. So notice that it just moved farther away from the origin. We'll talk about that in just a second. So B is 6, 2. So there's the bottom of my new triangle. And C is 2, 8. So there's C prime. So you can see that our triangle is bigger. It is supposed to be bigger. That is absolutely correct. But you can also see this side effect here. I'm going to show you. So before we were kind of 1 square diagonally away from the origin, and when we double set the size of the shape, you notice that we're now twice as far away from the origin. We're now 2 diagonal squares away from the origin. So that's kind of what I was saying a minute ago about how when you make a shape bigger, it pushes it further away from the origin. So this triangle is twice the size. If you look, the bottom side is twice as long, and side AC is also twice as long. So the sides all got twice as long, kind of mirroring what's going on. But it also got farther from the origin. So that's why you should use your rule to actually calculate the coordinates and then graph it so that you can make sure that you're in the correct location on the graph. Because you can't just make it twice as big and put it wherever you want it. According to the rule, it lands in a very specific spot on the graph. So that is a little bit more information and kind of a wrap up of some of the things that you were noticing, hopefully, on your dilations introduction that you did ahead of this activity. So at this point, you should have all your dilations notes filled out. And then when you're ready, you are going to work on an assignment to summarize what we have talked about dilations. So when you're ready, you can go give that assignment a try.